I'm Anil Kumar. In this video, we'll try to understand extreme values in closed interval. I have a statement here which says continuous function in closed interval will always have absolute maximum and absolute minimum values. Now this statement is also popular as an extreme value theorem. So theorem states that if we have a continuous function in a closed interval, it will always have absolute maximum and absolute minimum values. Let's try to understand it. So let me sketch few graphs to illustrate. Let us say the interval is from A to B. So we'll take a closed interval. Closed means including both endpoints, which is normally shown with square brackets. Continuous means without a break. So if between A to B, if we have some function, let's say kind of like this, where these two endpoints are A and B, in that case, you will always see that we have one value which represents absolute maximum, and there will be another value which will represent absolute minimum, as shown here, right? So the graph could be in different ways, like it could be like this also, kind of like this. You see one maximum value and one minimum value. So always in a closed interval there will be one value in between A and B. Let's say the value C. So when we say absolute maximum, that means the value of the function at C is greater than any other value where x belongs to the interval A to B, right? Since C is within this interval, we'll say greater than or equal to. So it is going to be equal to at C, right? Similarly, for absolute minimum, we can say there will be another point, let's say D, where the value of the function will be minimum. That means less than or equal to f of x, where x belongs to any real number between A to B, right? So the first one, that is the highest value, represents absolute maximum, and the other one represents absolute minimum, right? So that is, in a way, we could explain what this extreme value theorem is. Okay, so that is the basic concept. Now in this, there are important constraints, and there are two constraints which we have seen here. First constraint and the second constraint, can you list those? The first one is we have closed interval. Like AB, right? That means including both A and B. And second is the function should be continuous. These are the two constraints. Now if any of these is violated, in that case you may not have both absolute maximum or minimum. To give you an example, let's take an example where we can violate these conditions and we can see that the function may not be a maximum or a minimum. For example, let's consider the interval between A and B. And if it is not a closed interval, let us say this is open interval. So the point at A is not included. And we have something like this. Point at B is included, for example. In that case, let us say this value is at 1. then we know that absolute minimum does not exist. Because we're very close to 1, but we don't know what that value is. You get an idea. We could have a function which could be kind of like this. Let's say it's kind of an asymptote somewhere in between. So let me draw an asymptote here. That means the function is discontinuous, and let's say this value is defined here, and we have a value here, right? Now in this case we have a closed interval a and b. However, the function is discontinuous. So what do you observe here? That we do not have no absolute maximum, right? Since it is approaching infinity, which is not defined, we do have absolute minimum here, right? We have an absolute minimum in this case. However, we do not have absolute maximum value. Do you get an idea, right? So these are very important constraints to consider when you're discussing extreme value theorem. One, we are always considering a closed interval, that means including both the endpoints, and second, the function should be continuous. Correct? Now based on this, let's have an example, and then we'll move forward to understand how to write an algorithm for finding extreme values. Now let us discuss the algorithm for finding extreme values. As an example, let's determine absolute extrema of y equals to x cubed minus 3x squared, where x is greater than equal to minus half and less than equal to 2.5. Now the steps involved are, first you should check that it is a continuous function in closed interval. Which it is. Cubic function is a polynomial and the interval includes both the endpoints. That means it is a closed interval. The second step is to find the derivative of the functions. So we'll find critical points. Find the derivative. So if derivative equal to 0 or the derivative does not exist, then that will give us all critical numbers. And third step is to compare the values at the endpoints. Let's say the endpoints are from A to B. In that case, we have to find the value of the function at A, the value of the function at B, and the value of function at all the critical numbers, right? So we say C's, all the critical numbers. So comparing these, we are going to get the answer. So these values, above values, will lead to absolute extrema. So let's perform all these operations on the function, which is y equals to x cubed minus 3x squared. So the derivative of this function is 3x squared minus 6x. You could actually factor 3x. You get x minus 2. So the critical numbers are x equals to 0 and x equals to 2. Right? So these are your critical numbers. So now we are going to find the values at x equals to 0, x equals to 2, and these two extreme values, right? So we'll actually take a calculator to calculate these values. So the value of the function at 0 is, substituting 0 we get 0. The value of the function at 2, so these are the critical numbers, will be 2 cube minus 3 times 2 square. So let's calculate. We have 2 cube minus 3 times 2 square. Let me put it in bracket, and that gives you minus 4. And now let's find the value at 0.5 minus. So f of minus 0.5 will give us minus 0.5 whole cube minus 3 times 0.5 squared. Let's calculate this. So we have within brackets minus 0.5 whole cube minus 3 times 0.5 whole square. That gives us a value of minus 0.875. And now let's also calculate the other extreme value, which is f of 2.5. So it is 2.5 whole cube minus 3 times 2.5 whole square. So that gives us 2.5 whole cube minus 3 times 2.5 whole square is equal to minus 3.125. Now if you compare these values, we have all negative values except for the first one. So this results into absolute maximum. Amongst the lowest values, minus 4 is the lowest, so we get that as absolute minimum, right? So that is how we can actually apply the algorithm and get our answer, correct? So you have to check the values at the critical numbers and also at the endpoints, right? If you sketch this graph, it may look like kind of like this. We have a 0 here, and from these values we can say that the function is kind of let's sketch it. So x square is common, so we could write x cube minus 3x square as x square is common, right? So we get x minus 3. So we have zeros at this turning point and at 3, right? So the function may look like, it's a cubic function with positive leading coefficient, something like this, right? But since we have boundary conditions, which are from minus 0.5 to 2.5, so it looks like from this point to that point, correct? So that becomes the function. And clearly from here you can see that we have absolute maximum at 0, 0 and absolute minimum at the other critical number, which is 2 minus 4, right? So that value is minus 4 for us at 2, right? So that is how you can actually use your algorithm for finding extreme values. Now let's move on and take a multiple choice question. The question here is, which of the following will have absolute maximum and minimum values? Explain your choice. Now in such questions, you should observe two things. First is, we are looking for boundary conditions, which is closed interval. So we have two options here, right? These two have closed intervals, the others do not have closed intervals. Second is continuous. Now see, minus 1 over x plus 1, here at x equals to minus 1, we have a vertical asymptote. Therefore, it is not continuous. So that is not the choice. Now, a cubic function is continuous. And we do have a closed interval, so that becomes the choice. Right, so this is kind of straightforward. So you look for two things. One is the closed interval, and the second thing is that it should be continuous, right? So I hope that makes sense, correct? Now let's take up a thinking question based on the extreme value theorem. Now here is a test question for you. The question is to graph a cubic function with absolute minimum at -2, -10, local maximum at 0, 1, local minimum at 2, -2, and absolute maximum at 4, 11. Part B is write what is the domain range of this function, and part C is write the increasing and decreasing interval for the function. Right. So first part here is to sketch a cubic function with given information. I would like you to pause the video, answer this question, and then look into my suggestions. So let's make a rough sketch here. What we are given is absolute minimum at -2, 10. So somewhere here, let's say this is our absolute minimum at -2, 10. Okay. Local maximum at 0, 4. So let's say this is 0, 4 local maximum. So it has to be a turning point. Local minimum at 2, -2. 2, -2. Let's say this is another turning point. And then absolute maximum at 4, 11. So somewhere here, let's say that is our point. Now we are also given that's a cubic function. Now cubic function can have absolute extrema only for closed interval, correct? Otherwise, it extends from one infinity to the other, right? Closed interval. Keep that in mind. Only then you can sketch it. Otherwise, it kind of becomes difficult. So what we will note here that these 2 points are the extreme values. These two are the extreme values for us, right? So, and in between, the function has a turning point at local maximum and minimum. Do you understand? So that is how the function should be sketched, where the given points are -2, -10 as one extreme, the other one is 4, 11. Right? This point is given to us as local maximum, and that is local minimum at 2, -2. Now once you have this graph, you can easily answer the rest of the questions. So part A is done. That is the sketch. We have a cubic function restricted on both the ends. Now the domain of this and the ranges, let's write down. So the domain of this function is x belongs to real numbers, where x is between which two values? -2 and 4. As far as the range is concerned, so let's say y values will be y belongs to real numbers, where it goes from -10 to 11. So that becomes the domain and range. The second part C is write increasing and decreasing intervals for this function, right? So what is the increasing interval? So let's write down. Increasing interval is, so it is increasing from -2 to the turning point, which is at 0, and then from this point, which is the other local minimum, which is at 2 to 4, right? Union we can write 2 to 4. So that is the increasing interval. As far as the decreasing interval is concerned, it is decreasing in between from 0 to 2. Correct? So that is how you can answer this question. So I hope it makes sense. Now with these examples, I hope we have got some understanding of extreme value theorem. Feel free to write your comments and share your views. And if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.